Here we start on the SafeSurveil-AIxBio dashboard. This page confirms the system is running in live mode, persisted backend jobs, live evidence, and no active blockers. It also shows which external AP is and local tools are configured, including OpenRouter, Thesis, AMRFinderPlus, and MASH. Before trusting any case result, the operator can first verify that the runtime is healthy and not silently degraded. Next, I'm opening the live analysis intake page. This is the front-end entry point for creating a real back-end job, not a static demo card. I'll enter a sample ID for this run. demo_video_live_ecoli_teti_202600426. The target drug is tetracycline and the organism hint is E. coli. For the FESTA input, I'm using a genome file that was already retrieved through the phase 6B live retrieval flow. So the front end is submitting a local path to a real retrieved FASTA, and the backend will validate that path, run the analysis workflow, persist the job, and create the evidence artifacts. I'll also add the accession GCA_00128362.5.2, set the source context as agricultural surveillance proxy, and set provenance source as NCBI datasets. These fields matter because SafeSurveil separates input provenance from model provenance. The sample input can be live retrieved, while the current predictive baseline is still clearly labeled as a fixture trained smoke baseline. Now when I click create analysis, the front end sends a real post/job/analyze request. If successful, it redirects into the persisted case screen for the newly created job. Now we're on the main case decision screen for one persisted genomic triage job. At the top, we see the final triage decision: severity, actionability score, sample context, rationale codes, and recommended next step. For this case, the system recommends deferring to lab confirmation instead of taking immediate action. Next is the runtime verifier result. This is the safety gate that checks identity, citations, numeric consistency, policy alignment, and evidence coverage before AI-assisted outputs are trusted. The decision signals show the main drivers: resistance probability, actionability, novelty risk, QC risk, and prediction uncertainty. This explains why a high resistance probability alone does not become an automatic act decision. The guardrail panel makes the boundary clear. The persisted decision object is the source of truth. The LLM and renderer are sidecars, not decision makers. Then we have the bioreason style trace, which walks through 8 structured steps from sample context and AMR mechanisms to phenotype prediction, novelty, QC, actionability, and final triage. The graph or decision map turns this into a visual evidence network linking sample, organism, drug, genes, mechanisms, citations, and final decision. The evidence table and raw metadata then show the AMRFinderPlus rows, artifact paths, hashes, and previews. Finally, the shift profile, decision signal balance, case explanation, evidence limitations, and allowed next steps explain the practical conclusion. This case has mechanistic signal, but novelty, QC, metadata, and actionability constraints make lab confirmation the safer recommendation. Next is the analyst queue. This page turns persisted backend jobs into an operator workflow. We can filter by triage status, search by job or sample, sort by actionability, and open any case directly. The queue also shows the ACT, review, and defer lanes. So analysts can compare how different cases are being routed instead of inspecting each result in isolation. This is the fallback renderer and thesis boundary. Thesis C1 can render the semantic UI into a richer presentation, but it is never the source of truth. If C1 fails or returns unavailable, the React fallback still shows the back-end grounded decision, risks, evidence summary, queue context, and safety notes. So presentation failure cannot hide the case. This is the final audit and proof page. It collects the closure checks in one place: backend health, live operating mode, integration readiness, queue state, selected job persistence, artifact coverage, copilot live mode, thesis readiness, runtime verifier, reasoning trace, and evidence graph. This page is our sign-off surface, showing that the demo is not just visually working, but backed by live APIs and auditable evidence.